recording. Okay, so review about the power. Okay, so now we go back to review about the power. The question is that, we can see that b to the power 2, b to the power 3, but can we also see that b raised to the power of a fraction? Right? And b raised to the power of a negative number. Right? Or b raised to the power of a negative fraction. For example, suppose I have 2. 2 is the base. What will be 2 to the power half mean? Right? And this is what it is. 2 is the base. Okay, so we have 2 as the base. On this fraction, there's a numerator. The numerator goes here. The denominator 2 here goes there. And by default, of course, this is just square root of 2. So square root of 2 has a new way of expressing it. Does that sound a bell? Have you guys seen this before? Have we forgotten? I have some exercise for you on this in this aspect, but do you guys get it? Are you guys following me?
Yes.
Okay, so the next one, right? You get this, right? 2 to the power half is root 2, basically. It's just a different way of writing it. So this is the radical form, and this is the exponential form. How about 2 to the power negative 1? 2 to the power negative 1 is 2 to the power of 1 under 1. And this is really 1/2. Have we seen that before?
Yes.
Yes, okay, good. I will assign you exercise for you to refresh this piece, okay? And 2 to the power negative 3rd. What would that be? That will be 1 over 2 to the power of positive 3rd, okay, which is going to be 1 over root 3 and 2 raised to the power of 1. And of course, 2 to the power 1 is just 2. So 2 to the power negative 1/3 is really 1 over cubic root of 2. So this way, the base can be, pretty much any number. And the exponent can be any number. So we're going to use x. So this evolves to b to the power of x. And x, okay, I'm about to tell you the domain. X is any real number. But in most of the topics you study, okay, this course and next course, calculus classes, we will use the base, okay? Our base of choice will be positive and not equals to 1. Then you say, could I choose a negative number as a base? Sure, you can. You can. But in exponential function, as we study it, okay, for exponential function, the base will be chosen this way, okay, for exponential functions. Okay, exponential function, in the exponential function we are considering, right? You certainly can have base be negative. You're going to see that in your calculus too, but when we talk about exponential function, the base will be larger than 0 and not equals to 1. So in other words, the base is going to be positive. Okay, so these are the examples you see in basic 1 in that table, where you see number 9, number 10, number 11, and number 13. 9, 11, 13, right? We use the base 2, base E, and base 10. So we'll consider these three cases. We may not do every one of these in great details, but this one we're going to do in details. Okay, then your question is, what is the value for this guy? Well, if you if you plug in this in calculator, you're going to get a number. And that number is going to be a meaningful number. And what is more, this number is going to be larger than 0. And of course, this number is larger than 0. And this number is larger than 0. Okay. And all the rules, okay, all the rules we have learned, right? B to the power m multiply b to the power n. Someone just mentioned that, is it going to be m times n, or is it going to be b to the power m plus n? Which one is correct? Of course, there's only one correct answer. Which one is correct and why? Which one is correct? And how to figure out? Once again, not to figure out, how to figure out. I try to teach you a way that you don't rely on your memory. You rely on some basics and reason your way through. Would you like that? I think you might like that, don't you? Who wants to memorize, 200 formula? Who wants to remember 200 formula? Or I can give you less, 50 formula. Who wants to memorize 50 formula? No one, right? Am I agree? Am I right with you? Who wants to memorize 100 formula? 50 formula.
Not me.
Not you, Nicholas. Okay. Not me either. Farouz?
I rather create 50 flashcards for each formula.
Yes, you can create 50 flashcards, but what if the flashcard is not allowed?
When I create the flashcard, during the process, I learn them.
That's a good idea, right?
That
But
is what you mean.
yeah.
Practice, practice, practice. Yes,
Right.
thanks.
True. But oftentimes it's not necessary to memorize if you can figure out. Okay, and in a lot of cases, to figure out is pretty straightforward. So I'm going to show you how. Okay, I'm going to show you how. So I'm not going to tell you which one is right or which one is wrong without a reason. Okay, because I want to show you how to figure out yourself. Okay, for example, what does b to the power m multiply b to the power n means? Right? Take the example, put a 3, put 2. This is not a proof, this is just an anecdote, right? But this will be a place to start. So I'm going to do it, I'm going to call it think out aloud. Okay? So b to the power 3 means what? E times b times b 3 times, right? B to the power 2 means b squared. So this is b to the power 3, and that's b to the power 2. I can remove the parentheses. What do I end up with?
B to the power 5.
B to the power 5. And 5 is what? is 3 plus 2. Right? And that already tell you this formula, this is wrong. And of course, we have to eventually prove this. And that proof will be pretty straightforward, right? So how do we prove it? If this were m and this were n, for the m part, right, I will have m b's, right? So these will be m. There are m of them. M times. On the b to the power n, what I will have is b times b times, and there will be n of them. So this is n times. So m times multiply n times of b. So you just count, right? 1, 2, 3, 4, m plus 1, m plus 2, m plus 3, and so on and so forth. So this is going to be what? M plus n. The earlier one is called an anecdote. The latter one is called a proof. And you can quickly jot this down from the basic concept. So you're going to figure out which one is right, which one is wrong. This is right, right? And the other one is what? Wrong. You guys follow me?
Mhm.
Yeah.
Okay, so that's a review about this property. There are some other properties I like to review with you since we're here. Okay, these properties will be pretty useful, right? So this one is wrong. How about b to the power m divided by b to the power of n? What would that be? Okay, I want to give you some time and space to figure that out. B raised to the power 0, what does that equal to? Right? So these are the basic facts of power. Basic facts about power. It's not a memory test. Okay, you get a piece of scratch paper, try to recall this, review this, and I have a set of exercise for you. And that should be basic 21. Okay, basic 21. Okay, it's for you practice. Okay, so I'm going to write it down. That's going to be in today's homework. Basic 21. And if you like, okay, if you have questions, don't hesitate. And basic 22. These are the exercises I gathered from, algebra texts. Basic 21, basic 22A, so on and so forth. Okay, you just go through them, and all the things you have learned before will come back. If you have forgotten, and you can figure out b to the power of m minus n. Very good. Okay, so this is b to the power of m minus n, right? So derive that. How about b to the power 0?
1.
Who said that?
Me.
Fransley? No. Okay, Andre. anything to the power 0 is 1. That statement need to be modified. Anything to the power 0 is 1. That anything has to be replaced by anything but 0. Okay, so this is true only when what? Only when B is not 0. Okay, guys? Then you say, what if, how about 0? What is 0 to the power 0? 0 to the power 0 is undefined. Okay, so I'm going to copy that. Thank you for your contribution, Andre. So look at the comments here. The comments is that anything to the power of 0 is 1. This statement need to be modified. If this statement is written as is, it will be a false. Okay, so this is a false. Okay, what will be true? Anything but 0 to the power of 0. That will be true. Are you guys with me? And the question is why? Is this just a rule enforced without any reason? Absolutely not. This rule is enforced and there's a reason for it. Okay, so let me explain to you why. Right? What do you get if you have B divided by B?
1.
That equals to 1, right? But according to this formula, right? B over B is B to the power of 1 minus 1, right? Because M is 1, N is 1. So that's B to the power 0. So B to the power 0 equals 1. But because B is used as a denominator, it cannot be 0. B cannot be 0. We never ever, you see, denominator cannot be 0 is a very ancient, quote and unquote, ancient rule, right? We don't divide by 0. Even though that rule was taught as early as pre-algebra, but that rule must be respected for all the future mathematics. Even when one day you go to Harvard, you major in mathematics. You go to Stanford, you major in mathematics, right? You study that amazing game theory, you know, you get Fields Medal and stuff. You still have to respect that basic principle. Denominator cannot be 0. Ground rule. And of course, there's a reason why we can go that way, but not now, okay? If you want to hear about why denominator cannot be 0, I will explain it to you, but not now, unless you request it, right? So anything but 0 to the power 0 is 1, right here. So whenever you quote this, whenever we quote this, we must specify the base cannot be 0, because without it, it will be a false statement. All right, very rigorous. So how about this guy? It would just be a to the power of n multiply b to the power n, right? That should be pretty straightforward, right? And this other one would just be a to the power of n over b to the power of n. Okay, since we're here, I'm going to give you a couple other rules that, properties that you need to review. Okay, which we have these examples. We had talked about these examples earlier on, right? So you have a fraction, right? You have a fraction. So we had this here, which you deal with a negative exponent, right? And we also have you have a base raised to the power of I'm going to put it as a fraction, p over q. How about that? Just for the fun of it, right? The base is b, the power is p over q. And that is related to root. That's related to root. So basically it says b, the base goes inside the radical notation. The denominator goes here. And the numerator goes to the power. You guys follow me? You can use any symbol you want, PQ or, whatever. I can use heart, and I can use, let's see, spade, right? And this heart is going to go here. Is in a position of numerator. And the spade is going to go there. You guys follow me?
Yes.
Similar practices you can find that I give you on yesterday, basic 33, right? Basic 33. That should give you quite a lot of exercise, and you might see something like that in Calc 2. Okay, you might see something like that in Calc 2. So that's it about reviewing for powers, right? So let's go back here. Let's go back here. Okay, so we are working with this function, this rule, right? And we realized, oops, sorry. What number will be qualified for the power? That's any real number, right?
Yeah.
Any real number means what? It can be negative number, positive number, fraction, decimal, rational, irrational. Okay. Any real number can be the power. The range, however, needs to be observed. So 2 to the power negative 3, what would that be equal to? I want you guys to roll up your sleeve, and now you start working on this table. Yes? What would that be?
I want to say 1/8.
Sorry? I didn't hear you, but 1/8, that's absolutely right. Is 1 over 2 to the power 3. Okay, so that will be equals to 1 over 2 times 2 times 2. So it equals to 1/8. 2 to the power negative 2. What would that be? I want you guys to finish this table to compose that input output. So when input is negative 3, the output is 1/8. The input is a negative, the output is a positive. Interesting. 2 to the power negative 2, 2 to the power negative 1, and 2 to the power 0, 2 to the power of half, 2 to the power 1, 2 to the power 2, 2 to the power 3. I chose some fractions there just to show you, you can have negative, you can have fraction, you can have any real number there. So what is 2 to the power negative 2?
One-fourth.
1/4. Very good. Okay, so it's 1 over 2 squared. Right? 2 squared is 2 times 2, and that's going to be 1 over 4. So that pair, input is -2, output is 1/4. Interesting, huh? The input is negative, the output is positive. I wonder if that's always true. 2 to the power -1, what would that be?
1/2.
1/2. 2 to the power 0.
1.
2 to the power half. √2. Okay, 2 to the power 1, 2. 2 to the power 2, 4. 2 to the power 3, 8. Does everybody follow?
Yes.
Input is -1, output is half. Input is 0, output is 1. Input is half, output is √2. √2 is a number between 1 and 2, right? If you really want to get a numerical approximating number, it's just going to be 1.414, blah, 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 followed by many digits. But you just have to know it's a number between 1 and 2, right? And for those other ones, 1, 2, input output 2, 4, input output 3, 8. And then what do we do? In the process, okay, I observed something interesting. Okay, yes, the input can be -0, positive. But it looks like my output are all positive. I wonder if that's always true. Do you guys notice? The input can be -0, positive. And the output, right? This is called a cross-examination, right? Across the points. The output is positive 1 by 1. You just wonder, do I ever have a negative output? Do you think we ever will have a negative output? And also, is it possible to have an output that's equal to 0? Do you understand my question? I'm going to write down the question. Oops. Okay, observing the input output. The input can be any number, any real number. Positive, zero, negative. The output in the table are all positive so far. Just wonder, when will the output be 0? When will the output be a negative number? right? So if you observe this rule, the input can be any real number because we're heading to find the range, right? And so far, the output we get, they're all positive. We haven't got a zero output yet. We haven't got a negative output yet. I would just wonder if we're going to get something like that. So would that be a question to ask based on what information we have? Yes. And it looks like the output, as we going from -1, -2, -3, the output is getting smaller and smaller. Do you see that? So now let's plot the points. Okay, we have 1 minute left. We have 1 minute left. Okay, I have given you all these questions I want you to think about. Okay, and next, we may not be able to finish in class, but I want you to plot the points with me. Okay, so I'm going to put this table on the side. Okay, I'm gonna set up my rectangular system. At least I'm gonna get you started. Right, I'm gonna get you started. And I'm gonna start plotting the points. Okay, I'm gonna start plotting the points. The first point I'm gonna plot is gonna be -3, 1/8. -3, 1/8. And that's going to be a dot on my graph. Okay. Oh, -3, 1/8. I must have typed something. I need to make some adjustment. So -4, 5, -1, 10. The scale need to be worked out, right? It's right there. So this point is -3, 1/8. So I want you guys to, after class, to plot one by one these points. And the next point, red dot there. And you mark each point. Okay, so I'm going to show you how you mark each point. Our time is up. So I'm going to show you how you mark each point. See, for example, the first point, right? The first point. The first point is input is -3. The output is 1/8. Then the second point is -2. And the output is 1/4. Okay, so one by one, I want you guys to plot these points and I'm going to see you tomorrow.
Thank you, Professor.
Have a great day. Thank you so much.
All right. Thank you.
Thank you.
Thank you.
Thank you, guys.
Thank
Good
you.
job.
Have a
Please
good
do
day.
this. I'm going to write down your homework. Anybody has any questions? Anybody? Anybody has a question?